We'll continue from the topic we have left yesterday. We'll see isotherms now. So we are dealing in atmospheric temperature, right? So after doing a fundamental, let us take one review. So after doing enough fundamentals, we are dealing in atmosphere and and what we have seen in atmosphere, that atmosphere is itself is a system, and this system comprises of three components, and these components are temperature, pressure, humidity, and these receives a heat energy from solar radiation and terrestrial radiation. Okay, and we have noticed what? That the amount of energy inflow is what? Same or different every day? Amount of energy coming in is same. Solar radiation which is coming to earth is same or different? Same. But we receive, absorptions are different in different latitude and different in different hemisphere, right? The sun throws same amount of light every moment, but we receive different in different time because of spherical nature of the earth, because of the tilt of the earth, right? So that is how the inflow is same or different. Inflow is same, absorption is different. Have this idea, right? These two are different, right? The rays are all the time parallel to us, all the time parallel, but because of the tilt and because of the sphere, and the tilt equation also changes sometimes, that is why we have a different absorption. So energy received is what is different, and that is why their behavior will going to be different, because when we are going to supply temperature, heat to the atmospheric system, it will alter pressure, that will alter humidity, that will alter temperature again. So their behavior will keep on changing all time, right? So, and their behavior will give a results in terms of air circulation and precipitation. Okay. So we have dealt with the temperature aspects. We have seen temperature. Now we have two important components left in the temperature, that is heat budget and temperature inversion. Okay, but before that, we'll see what is isotherms. Last day we have learned that the distribution of temperature is also affected by different determinants. What all determinants? Latitudes, altitudes, land water distribution, you know. Yes, orientation of mountain, ocean currents. Very good. देखो ऐसे रहना है. If once you have studied, you have to have an idea all the time clear. Right? Well done. And these study material, this case studies, will going to give you some opening about some concepts. Last day you might have noticed the opening, how the tilt is giving an opportunity for Siberian birds. You know, because we have a winter comes, they get in a comfort climate to the tropical region, and when they are going back, they get in a biodiversity burst. Is that idea clear? Biodiversity burst. It happens where? In equatorial region or in Siberian land? Siberian land is unique to the biodiversity burst. But there is a disturbance in this process due to climate change, and that is known as phenological mismatch. So these are the keywords. Okay. Okay. Now we'll see isotherms today. So we are dealing with a temperature. Now we'll speed up class, right? now you can capture concept. Once the basic done, you will capture concept. Okay. So now we'll see isotherms. Isotherms. So this is what type of a concept it is. Isotherms are imaginary lines where in a map, I'll dictate, don't worry, don't write. So class timing is 8, na? Class is at 8. हाँ metro थोड़ा सा करता ही है. I also have a problem. So we'll make up because those who are following the things in disciplined manner, we should not penalize them. आप समझ रहे हो ना? That is why I used to start class at 8. So isotherms are imaginary line. This represents what? A region with same temperature. Right? This represents a region with same temperature. Suppose we have a one place where we have a 40, 40, 30, 40, right? So isotherms normally goes like this way. That is an isotherms. That will goes like this way. So it connects region having a same temperature. Now, so we have the distribution of land and water is like this way. Land dominates more on the northern hemisphere. Water dominates more in the southern hemisphere. So where you see between northern hemisphere, southern hemisphere, when I am going to put, normally isotherms run parallel to latitudes. Normally it run parallel to latitudes. Why? What is latitude? Like if I'll say what is latitude, so we have equator, right? We have different latitudes and then we have a poles. Okay, poles. So what is your learning now? What latitude defines? Latitude also represents amount of insolation absorbed. You know? Higher the latitude, absorption would be less. So it is also an indicator of absorption, right? So just having these idea, okay, these are the parallel lines, but these are the indicator of absorptions. These are the indicator of inclination of the slanting rays and perpendicular rays. So the same latitude, one same latitude having the same potential. What latitude will receive light here, they all will receive light here. The absorption capacity of all these points are same if they lie on the same latitude. Why? Because the latitudes are parallel and with the rotation, every places of the same latitude will come in the sun, in front of the sun, right? So that is why the latitudes and the places on the same latitude represents the same amount of absorption of same amount, right? And now it varies because of the nature of the land, that what we have learned yesterday. Okay? So that is why isotherms normally runs parallel to latitudes. Okay? Why it runs parallel to latitudes? Because places in latitude represents same amount of absorption. देखो ये समझोगे ऐसे आप ना. Let us see. If we have summer, sun is in your side, ठीक है, and we have India. Summer is very hot, 90 degree at India, ठीक है, June 90 degree India. Now because of the rotation, all latitudes parallel to India will receive 90 degree. 90 degree in India, 90 degree in same places in Pakistan, Iran, Afghanistan, सब जगह आएगा ना. everywhere. So latitude represents same amount of inclination, hence same amount of absorption. अब क्या होता है? What happened? And that is why isotherms runs parallel. Normally it runs parallel. But the absorption also depends on nature of the surface. You know? Because land and water में which surface will absorb things fast? More? Land. Yesterday we have seen. You know, water has a high capacity, specific heat. They can store, they can distribute. So, normally what happened, isotherms run parallel, normally. But when we have a summer in the northern hemisphere, what season we have a summer in the northern hemisphere? June, July, we have summer in the northern hemisphere. So sun is where? Here. Which sun? Overhead sun is there on the Cancer, Tropic of Cancer. Now, Achha, is this diagram clear? Is this diagram clear? What this represent? This area? Land. Good. So we have a land, water, land. Okay. So suppose we have a sun is there and throwing a perpendicular rays. So let us assume in this line, that is a line represent the latitude. So what would be the temperature? Let us assume we have a 40-degree temperature here, 40 degrees centigrade. And there again we have a 40 degrees centigrade, 40 degrees centigrade, because the land was the same will going to face, come in front of the light, sunlight, 40 degrees. Now what do you think would be the temperature of the water body here exactly on the same latitude? Higher than the 40, exact 40, or less than the 40? Less than the 40. So we have a less than the 40. Okay. And let us suppose here it is more close to this side. We have a 45. We have a 45. Hai this side also we have a 45. Here it would be less than the 40, 45. So let us suppose we have 40 here. Okay? Assume karte hain, we have 40 because the water has a temperature less than its counterpart on the same parallel latitude, right? Now if we move forward, if we have a 30 here, 30 there, it would have a 20 here. ऐसा होगा ना? So now see what is the nature of the isotherms. In summer, isotherms is bending towards equatorward. है ना? Where in the northern hemisphere? When summer is there, isotherms is bending towards equatorward. Is that idea clear? Concept clear है ऐसा ना? Why? Because specific heat of water is more, and that is why it does not give in the same reaction if they receive the same amount of absorption of sunlight. Right? Now what if we have a winter? Rate of cooling is faster where? On land or water? Land. So rate of cooling is faster on land. So rate of cooling. So let us suppose if we have here, if we have a 20 degree in winters, no? Northern hemisphere in winters. Northern hemisphere in winters. What would be the temperature here? More than 20, less than 20? Water bodies mein. If the cooling is there, winter mein. More. Because land cools fast, you know, and it heat ups fast also. So we have 30 degree. You know, it's warmer then, because as we have seen yesterday, the specific heat is much higher. That is why losing and gaining is very slow. It loses heat very slow, gains heat very slow. And that is how we have, if we have a 30 here, it would be 40 this side. You know? So in winters, What is the nature of the isotherms? It bends towards poles. It is bending towards poles. So let us draw. इसको draw कर लो जल्दी से and write isotherms के बारे में. I have given notes on isotherms to you. Lecture notes are there with you, na? So write isotherms. Write isotherms. Write then draw. Don't worry. Isotherms are imaginary lines. Isotherms are imaginary lines. Imaginary lines drawn on a map. Drawn on a map that connect places with same temperature at a specific time reduced to sea level. Right, next point. They essentially give us a visual representation of how temperature varies across the globe. Right, next paragraph. These lines are particularly helpful for understanding seasonal temperature distribution which can differ significantly. Distributions, comma, which can differ significantly. No? Right, its salient features. To write one point, na, point wise, because the detail is with you. I have already given. Isotherms wala notes mein na, you will find everything is written. To write in summers in northern hemisphere. Isotherms bend towards equator. Isotherms bends towards equator on ocean water. On ocean bracket में water bodies. Towards equator. देखो bends towards equator है ना, on ocean water. ठीक है, हाँ, on ocean water. Right, next point. While in winters in northern hemisphere, it bends towards poles. On ocean surface, oceanic surface. On oceanic surface. ये देखो आप, it is bending towards on oceanic surface. Bends towards ocean, poles on oceanic surface. ठीक है? If you like, you can draw. चाहो तो बना भी लो. Like everything is written in your notes. जो मैंने दिया है printed notes. Each and everything is written. आप खुद बताना, try करो जरा. Isotherms, try करो जरा ना. देखो मैं और भी question develop कर रहा हूँ. I am developing more questions, right? Isotherms represent places having a Same temperature, right? Where the temperature behavior is very much rapid, on land or on water? Land. No? Why it is rapid? The exact logic is low specific heat. मतलब it is very responsive. कुछ जैसे आपके दोस्त भी होंगे ना, कुछ छोटी सी बात पे रिएक्शन दे देते हैं ना, छोटी सी बात पे. Sometime your friend is also going to give a reaction on the little like a matters. So that is the same with the land. With a small introduction of the heat, it gives a response. More will give, you are going to give a noticeable response. So where the isotherms are more concentrated and more where we have an irregular isotherms, northern hemisphere or southern hemisphere? Northern hemisphere. We have irregular isotherms. Na? इसको भी लिखते रहना. In northern hemisphere, we have more irregular isotherms. More irregular isotherms because of uneven distribution of land water. Because of uneven distribution of land water. अच्छा स्लो बता देता हूँ. ये दोनों लिख लिया, winter summer. Right, in northern hemisphere, distribution of isotherms are more irregular. In northern hemisphere, distribution of isotherms are more irregular, but it is more regular in southern hemisphere. ठीक है. अच्छा, कहाँ पे isotherms between the northern hemisphere or southern hemisphere, where the isotherms were arranged very close to each other? Northern hemisphere, na? Because concentration land के ऊपर their arrangement is very close to each other, because the every next latitude में lands gives a very different behavior. So right, in northern hemisphere isotherms are closely arranged. In northern hemisphere, isotherms are closely arranged. ठीक है. Whereas in southern hemisphere, अच्छा मैं बता दूं. Whereas southern hemisphere, isotherms arrange in a wider or spaced manner. Wider and spaced manner. What is a space? So let us see first what is close. When two isotherms are very closed, है ना, इसको बोलते हैं closed arrangement, closed. And when there is a space, है ना, we have a space, so we call it in a spaced arrangement. Spaced. Isotherms are spaced, arranged in a spaced manner, right? So between land and water, if we have a land one side and the water other side, where the isotherms are closely arranged? Land. In land it is closely arranged, because every land with a little change in angle of inclination of sun rays will give a different behavior, whereas water has a tendency to distribute. So here the isotherms are spaced, because it has a tendency to expand and distribute temperature. So the isotherms won't be having an arrangement very close. The close arrangement is a phenomena of land. समझ पा रहे हो आप? नहीं. अब देखो, see, if we have a perpendicular rays and we have inclined rays on a land, so every point you will cover, you will get a different temperature. But what happened in a water, if we have a perpendicular rays and inclined rays, water has a tendency to move, it will distribute temperature. So that is why isotherms are spaced on water, closed on land. Is that idea clear? Because water has a tendency to move and distribute. So that is why between northern hemisphere and southern hemisphere, where the isotherms are closely arranged? नॉर्दर्न हेमिस्फीयर, तो इसको लिख लेना आप. सो आइसोथर्म्स आर, लिखा हुआ है ना, दैट वी हैव डन. आइसोथर्म्स आर क्लोजली अरेंज्ड while, लिखा है ना अभी तो, while in southern hemisphere we have spaced arrangement, spaced arrangement. अच्छा, एक और चीज देख लो, let us see one more, though it is not in a part of अभी it is not yet introduced. Last day we have seen that we have equator here, land, water, land, and we have seen that we have ocean currents. We have seen ocean currents. These are the rivers. I have given an introduction only. The detail we'll see in oceanography. Okay. So this side, this is what type of current? Cold or warm? Cold. If anything is coming from the pole, cold, cold. And this is warm. Okay. And there we have cold again and warm again. ठीक है ना? And let us suppose we have a latitudinal temperature. Latitudinal temperature is there. We have, let us suppose we have a 40, 30, 20 and 10, okay, 0 like this way. अच्छा, यहाँ पर भी we have a 40, 30, 20, 10 and 0 onwards ऐसा. So let us assume that we have an isotherms is going here, like we have 20-degree isotherms is moving. What would be its behavior here? Because the warm water is coming of 30, so it will have any change, impact, surface में होगा ना? So it will move where? Upward, because it is bringing in a water of 30 here, नीचे से आया ना? 20 would be here, so it will bend towards north. समझ पा रहे हैं ये point? Because the warm water is coming from this side, making water warm, so isotherms will make like a little bending this side. और यहाँ पे क्या होगा? Because we have a cold water, 10 water is coming here, it will bend like this way. समझ पाए? फिर से देख लो आप ना. These are the temperature developed due to insolation. Let us suppose insolation. But what happened? We have in the corners we have a warm water. Warm current is there, bringing warm water of equatorial region in temperate region. Warm water of equatorial in temperate. होना चाहिए था यहाँ पे temperature 20, but because of the warm water coming from the equator, it has a temperature 30. Its 20 is displaced towards north. So that is why when the isotherms will come, it will bend northward in the warm water, है ना? And opposite will going to happen here. It will come southward. So draw this line. हाँ, तो एक isotherms नहीं होगा ना. See, this is a 20 isotherms. We have a 30 isotherms. It will behave like this. There is a 40 isotherms. It will behave like this. हाँ, हाँ, सब ऊपर की तरफ चल जाएंगे. In summer, every isotherms will shift towards north. ठीक है. The only question is, does ocean currents also impact distribution of isotherms? Yes. It bends. इसको मैं फिर से बता देता हूँ. Let us draw. I'll explain again. Isotherms का क्लास में लेट आए ना, तो वो बता दिया मैंने. These are the imaginary lines only, है ना, which is used to get a visual impression about atmospheric temperature. We have discussed. Okay, but like we need to come right on the time. I'll explain again, need not to worry, but like come on time. Na? So isotherms are actual line or imaginary lines? Imaginary lines. At a time it represents what? Global temperature distribution or regional temperature? At a time, अगर उसको पूरे को देखें तो ग्राफ में, basically it is useful for global temperature. At a time we can compare global temperature, two hemisphere and all. So it is more useful for global temperature. Regional and local temperature is described by Met department. They said what is the temperature today? It is a weather department of the country, city, gives an idea. So like isotherms represents global temperature. Okay, the detail is there in your notes. You go and read and then I will discuss. Na? Isotherms mein. Okay. So today topic is heat budget. So let us see heat budget. नहीं इक्वेटर के जस्ट ऊपर कर दिया मैंने. इक्वेटर तो ये है ना. नहीं नहीं ये मान लेते हैं 50 डिग्री एज्यूम कर लेते हैं तो इट विल ब्रिंग इन अ 50 डिग्री टेम्परेचर ऐसा इसीलिए डिस्प्लेस कर. अच्छा इज दिस कॉन्सेप्ट क्लियर? If it is not clear, need not to worry, like it will come again in oceanography. देखो it is difficult if you don't know what is ocean current, you cannot identify why do we have these bendings there. But my purpose is to let you introduce only. Ocean current also has an influence. Okay, so we'll take up new topic, heat budget. Heat budget. ठीक है. What is budget? Heat to you all know. It is an energy. Right? Heat is an energy. What is budget? जहाँ पे इनकम और एक्सपेंडिचर का ब्यूरो रखते हैं तो ऐसा होता है कि इनकम है एक्सपेंडिचर हीट के साथ. Income from the heat, it's okay, that is a common understanding we have. I just want to know what is the meaning. I'm not looking your standard of the knowledge, right? I'm asking this question to give you the clarity, realization. The main understanding is hidden where? In the words and their literal meaning. I have seen like a student have studied heat budget without knowing what is budget. And that is why whenever you ask budget, whenever the word budget comes, everybody visualize what? Finance Minister of India holding on a budget document. So budget means what?
When the resource is limited, but we have to divide it in. Management of funds.
But somebody has given an answer, na? What is a budget? Equilibrium. Who said equilibrium? Yes. It means equilibrium. Now there are two ways we can have an equilibrium. There are two ways. So equilibrium happened when we have things balanced and budget. The equilibrium can be studied under two ways, na? Balanced and budget. Now what is balance? When you go to the market, you buy something, and when you have to buy weight wise, you balance. So in market we do what? Whenever we buy any vegetable, we keep a weight here, 1 kg weight, 2 kg weight, and on the equilibrium level we keep a vegetable here, right? And then we balance, right? What is the nature of this weight? Variable or static? Fixed, static, you know? This weight is static. Now, budget makes a balance between two variable inputs and outputs. It makes a balance between flow and flow. It makes a balance between inflow and outflow. Is that idea clear? So, budget means equilibrium. Under balance, we make an equilibrium between two static variables. And here we maintain a balance between two variable components, two variable. Which one is difficult? Budget or balance? Budget is difficult. We do not have an assurity it will going to have the equilibrium, right? Sometimes disturbable. But like that is a unique feature within our atmosphere. It creates a budget. What it receives, it acts like a emit outside space so that atmospheric temperature of the earth, annual average atmospheric temperature is what? Is fixed at 15 degree. It is because of the global warming we have disturbed this pattern, and the temperature is gradually increasing. And that is where we have these like a research report with you. आज मैंने जो दिया ना, it is not research, it is a case studies. Case studies will give you the better understanding. Tomorrow you'll get in a research report. So we'll see the concept of a budget. ठीक है? तो इसको draw कर लो आप. Let us draw this. And write the budget is an equilibrium between inflow and outflow. तो एक बोल दो आप किसी को, तो मैं बोल देता हूँ. So, is there any problem with the cooling? Or अच्छा अच्छा. So as nobody is outside now, when somebody will come, I'll going to ask them. So what is budget? Equilibrium. Between what type of component? Fixed component or variable components? Variable component. And that is how it is easy or difficult? Very difficult. Right? It would be going to be even more difficult when we'll see the complicities. कितने लोग आके इसको वो करेंगे इसमें, right? So let us see. So in budget we see the balance between incoming solar radiation to outgoing. So what I'll do, first I'll explain all concept. Then I'm going to give you the dictation, and you will be having a write-up notes also. So in budget, in heat budget, we actually see the balancing feature of incoming short wave solar radiation. Is this acronym clear? Incoming short wave solar radiation, it got balanced by outgoing long wave terrestrial radiation. Okay? That is how we are going to see how it happened. And we have seen already that which one is a fast? Incoming is fast, outgoing is slow. Okay, na? So incoming is, even though it is fast, it is slow, but it got balanced. How it got balanced, we'll see. But what happened in summer season? In summer, अच्छा देखो, incoming is more a feature of, incoming is dominated where? In a daytime or night time? It's a day phenomena. And a day may it dominates. And the heat loss is the more prominent in night. So in summers, what is longer in duration? Days are longer or days are longer? We have seen already. So as days are longer than the night, hence what happened? Incoming short wave solar radiation is greater than the outgoing long wave terrestrial radiation. I am just giving in a one brief, detail we'll see. Just an overview, and then we'll enter into a micro details. So is this idea clear? ये ऐसा क्यों होता है? Why insolation amount is more? Because the duration is more, 14, 15 hours, 18 hours, right? So in summer season, we have incoming is more than outgoing. So what is the result now? We have a surplus of heat energy or shortage of heat energy? So we have a surplus. Surplus heat is there on the system, earth system, in summer. Okay? Okay, then in winters, what is more dominating? Night is longer or days are longer? night. And that is why outgoing long wave terrestrial radiation is more dominating. So we have outgoing long wave terrestrial radiation is more than incoming short wave solar radiation, and that is why temperature is what? Is deficit. We have a deficit heat. But overall, annually what happened? Annually, we have things are balanced. One time surplus, other time deficit, it is balanced. It is balanced annually. ठीक है ना? Annually it is balanced. It is balanced. So let us draw this equation and write one line so that introduction can start, and so that we are going to see the micro details of other topics. पूछ लो आप, कोई डाउट है इसमें? अभी डाउट नहीं आया होगा, डाउट तो इसके बाद आएगा. अभी तो आई हैव नॉट येट लाइक गिवन एनी आइडिया इसमें. और सिंपली लिखो आप एक, राइट वन पॉइंट, राइट बजट मीन्स बैलेंस. Budget means balance between two variables, that is between incoming short wave solar radiation, that is incoming short wave solar radiation and outgoing long wave terrestrial radiation, ठीक है, राइट. in summer season as incoming solar radiation is greater, than outgoing terrestrial radiation, comma, atmospheric temperature increases. Hence atmospheric temperature increases. Full stop, right? While during winters, outgoing long wave terrestrial radiation is more than incoming short wave solar radiation. Hence atmospheric temperature declines. Right, but overall atmospheric temperature is constant. At 15 degrees centigrade. Overall atmospheric temperature is constant at 15 degrees centigrade. ठीक है, ब्रैकेट में एनुअल एवरेज टेम्परेचर. 15 डिग्री इज एनुअल एवरेज टेम्परेचर. ठीक है. अच्छा, नीड नॉट टू वरी, लाइक अभी क्लियर नहीं हुआ होगा आपको ना, what is heat budget, like you got an idea na. Budget means balancing between two variables, right? Now let us suppose we have a sun this side, and from the sun we have radiation is coming. We have these radiation, it emits radiation, and this side we have earth. There we have earth, and the earth receives all radiation or some specific radiation. It receives only, not like a radiation which is coming towards Earth. So as it is coming towards Earth, this radiation, these all are solar radiation. SR stands for solar radiation. Okay, solar radiation, solar radiation. This is also solar radiation, but it has a specific name. It is an incoming. It is an incoming solar radiation. And that is how we take an acronym. इसके acronym लेते हैं. Incoming का IN, solar radiation. And we make what? Insolation. That is the insolation. अब देखो ये तो आप सबको पता होगा ना. You all know that it is insolation. But UPSC wants to know whether you have an idea better about insolation or not. Like you know the detailed ideas of insolation or not. So when we have coming, this insolation is coming towards Earth, we call it insolation. And तो पहले तो लिखो आप what is insolation, right? What is insolation? ठीक है ना? अच्छा, written? Okay. I am not going to dictate definition. It is not academic class. It is an administrative class. Here we need to generate points by thinking. Had I been here to dictate, it is already written there in your notebook. I'll give you the printed notes also. And with the dictation, you cannot have a competitive advantage. Because if I'm going to dictate, you will get a common content. What content you will going to write, everybody will write. And the things are there in the market. Every institute, every competitors will have the same stuff. But we need to defeat in competition. We need to have an extra idea. So that is what we need to generate. और वो मैंने आपको exercise बताया था ना, pen to write. What are the other uses of the pen? So think differently, right? So my point is, what is insolation? आपको बताना है, मैं नहीं बताऊंगा. मैं तो बता दिया यहाँ पे. तो try करो, जैसे raise करो, देख करके बताओ insolation और क्या features हैं. Yes. अच्छा, it is short. It is in a short wave ना, तो लिखते चलेंगे. चलो मैं approve भी करूँगा. And मैंने उस दिन exercise किया था. I have did this exercise. I told you ना, if somebody will going to create some extra point, innovative point, I'll give a star. So I'm looking for the star point. When you're going to have a visual, like a idea clear, you can generate too many points. चलो और बताओ आप. Okay, so within that only. So short wave, fast moving. Fast. और बताओ. It is? How? Good. It has unidirectional. Na? So right, it has unidirectional. Very specific. Unidirectional. Right from the sun to earth. Keep on writing. Na? Don't avoid. Unidirectional. And other radiations are unidirectional or multidirectionals? So insolation is unidirectional, whereas other are multidirectional. देखो ये differentiate किया ना हमने, ऐसे differentiate करना है. और चलो बताओ. Tell me more. It is okay. So it is an ordinary radiation or prime radiation? तो right, it is a prime radiation source, prime source of energy, prime radiation. प्राइम. अभी स्टार पॉइंट एक ही आया है स्पेसिफिक वाला, और सोचते हैं हम लोग. देख के बताते जाओ आप. कुछ भी सोचो आप. लाइक हैव अटेम्प्ट मिस्टेक्स, डू मिस्टेक्स बाय थिंकिंग दिस. इट इज रीच टू अर्थ. तो दैट इज व्हाट यूनिडायरेक्शनल ना. दिस इज ओनली यूनिडायरेक्शनल, इट विल रीच टू अर्थ. हाई that will come into speed, short wave, because we need to not to write common points, which is captured in a one macro point. नहीं, अभी तो insolation पे देख रहे हैं. What we receive. अच्छा, that is what happened after receiving insolation, ना? Okay, it is in a prime source for many activities, phenomena of the atmosphere. अच्छा, tell me, it is an occasional phenomena or continuous? Right, continuous. It is continuous. हाँ, no, तो that will come in short wave. Radiation में सारा कुछ आ गया ना, हमें थोड़ा अलग चीज सोचना है. अच्छा बताओ ये, what is this part? Insolation is what part of solar radiation? Major part, minor part और meager part? कितना रेडिएशन है ना इसमें से? And this is what? Major और minor? Minor. Minor में भी क्या होता है? When the sun radiate billions of radiation, we receive one. It is a one out of the billion. So it is a minor, major, minor or meager part? Meager part. तो लिखो, it is a meager part of all solar radiation. It is a meager part. Right? Is that point clear na? Yes. It carries multiple radiations, na? UV, infrared, सब कुछ. Visual rays, है ना? It carries in visual rays, multiple rays. Okay. So I have got these. हाँ, like देखो ये star point. It is a never-ending source of energy. Change हुआ ना? It is a never-ending source of energy. Never-ending, continuous, never-ending. Never-ending. So have you got an idea? What is the textbook answer? The radiation which is coming to Earth is known as insolation, incoming solar. But when you are going to apply logic, you will get a better idea. है ना? Visual rays, उसी में आ गया सब. It has a different, like waveguides are there. ना? Okay. So that way we need to see, yes. It? हाँ, it is received by, that is a part of the receive में ना. अच्छा, these are what? Zigzag movement or parallel movements? Parallel movements. तो लिख लो, the insulations are parallel movements of radiation. ठीक है? Insulation are parallel movements of radiation. हाँ, it is an electromagnetic waves. Actually मैं वो multiply हो रहा है ना, एक ही में आ रहा है ना, radiation itself is electromagnetic. Okay, अब तो receiving part में कर लेंगे. Have you got an idea? Have you like got an extra idea? And these points you won't find in the books. और यही, this is what will give you the edge over other competitors. Thought-led ideas. And that is what UPSC appreciate. It is an administrative class where the thoughts, idea will appreciate it more. Right? Because this is where the solution is. It is a sustainable source of energy. If it is a never ending, so we need to rely where? On a fossil fuels or solar energy. देख रहे हैं ना? We need to put, if you are wanted to make some research station or some like a scientific venture is there, where you want to allocate more of the fund, being in a finance secretary and all, for efficient use of fossil energy or to have a technology to capture more solar radiation. देख रहे हैं ना? Idea आ गया ना? So that is how the idea comes. We'll get an all-time relief when we're going to have a very better efficient technology to tap these all energy. We can like rectify all our deficit. So that is how we need to think and develop ideas. तो इसमें अगर आप लिख दोगे ना एक paragraph, if you write in a paragraph, you're going to be very innovative, very unique paragraph will come out. ठीक है? And that is how we have the exercise for today. आज देखोगे तो उसी में ऐसा exercise है. What is evapotranspiration? What is insulation? What is heat budget? So is that idea clear? Insulation incoming? Okay. Now what happened when we have these insulations are coming towards Earth, and let us suppose at a time we have 100 units are coming, like 100 parallel radiations are coming, right? So here we have the Earth, and this side we have the atmosphere. What happened? Out of these 100, if 100 is coming, all is not going to absorb by the Earth. Not absorbed. Some of it, after coming into the atmosphere, striking the surface, it is going to reflect back. It will reflect back. Right? So by atmosphere, also by surface. So we have a reflection. Reflection. Right? This reflected radiation is known as albedo. It is known as albedo. Okay? Now what is albedo? What is reflection? See reflection. Last class I have given a clue. In reflection, when radiation is coming, so we have absorption or no absorption? No absorption. Without absorption, if something is going back, we call it albedo. Albedo. So tell me whether it will going to participate in a warming of Earth system? No. It has a what property? Like a different property than solar radiation or same property? Same property. Because if the energy is not lost, it will going to hold all properties. It is coming, striking, and without giving anything, it is going back. Its energy, character, everything will going to intact. Right? What is the value of this albedo? Due to reflected. Have you noticed reflected rays? When we have a reflected rays, the surface will appear what? Dark or bright? Bright. It gives a shining or brightness to the surface. More the albedo, more the brightness. So, not all going to absorb. Out of this, 35 going to get absorbed, 35%. 35% going to get reflect. So, what amount is left now? 65. We have a 65. So, in a given time, if 100 units are coming, 35 lost, now Earth system has to manage 65 only. है ना? तो देखो एल्बिडो का कितना बड़ा रोल है. और इसी पे मैंने एक आर्टिकल दिया है, कल मिलेगा आपको, कि एल्बिडो सबसे ज़्यादा कौन, which surface will support reflecting more albedo? Rough surface or smooth surface? Smooth surface. And where do we have a smooth surface? Glaciers are smooth. Other than that, plains, okay. But which surface is a smooth surface? Like a rocky surface or sandy surface? Sandy surface. And where we have a sand? Deserts. You will surprised to know that the desert also plays a major role in creating albedo. It means what? It will see deserts from the space. Deserts will appear what? Dark or bright? Bright. So देखो, this is a picture. This is a real picture of an earth from the space. You can see bright color here. It is full of desert. इंडिया में देखो सबसे bright आपको इधर दिखेगा, राजस्थान, है ना? We have a what? Desert. So desert also plays an important role. So most important component which plays an important role in albedo is snow. ठीक है? Between North Pole and South Pole, we have snow lands are there. Which side we have a larger ice cover? South Pole. Where do we have a highest albedo? In Arctic or Antarctica? Antarctica. Antarctica is in a very highest albedo. So what would be the like a picture of the earth from the Antarctica? It is a dark place or bright place? Bright place. So brightness indicates possibilities of, okay, albedo nahi hai. That is a conformity of albedo. Brightness assured conformity of albedo, but possibility of ice. Ice hoga na? So that is what Indian scientists thought of. The moon also has a brightness in the South Pole. And that is why this mission, Chandrayaan 2. This is Chandrayaan 3, okay. And what was the name of the satellite? Pragyan. And the carrier was Vikram. That is why this venture was sent to the moon, with the hope that if we have an albedo is very high, आप moon को देखना, in a given day, in a given like a night, you go and see the moon. You will see the south side of the moon is very bright. It gives an idea that there would be a possibility that even the ice is not there in the surface, it is below surface. Right? That is why there is a somehow race for like landing their satellites in the South Pole. Okay. So albedo. So albedo is mostly affected by what surface? Smooth surface, है ना? Bright is a consequence. याद रखना आप ना. Bright is not a cause, it is a consequence. ठीक है? So, what is the albedo of an Earth? Earth का albedo कितना है? 35. What is the albedo of the Moon? More than 35 or less than 35? The Moon has 17 only. Moon's albedo is half of the Earth. Because what surface is normally there on the Moon? Smooth or rough? Rough. So its albedo is less than the Earth. It means if you find a place somewhere in the space and if you see the Earth and Moon together, you will find which body will have a more brightness? Earth. Earth gives more light than the Moon. Okay? Acha. So which one is having a maximum potential? Snow, है ना? After snow, deserts. Deserts gives a more snow, more albedo. Deserts. Is this things visible? पीछे दिख रहा है? अच्छा, I'll write here. Snow. After snow we have a deserts. Okay. अच्छा, आप चलो बताओ आप. Where do we have a possibility of more albedo? In a cropland or in a forest land? हाँ. कहाँ पे लाइट ज़्यादा एब्जॉर्ब होगा? क्रॉप्स में कि फॉरेस्ट में? फॉरेस्ट. Because of the photosynthesis, है ना? They absorb more light. So forest appear what? When we'll see from the space, it will be bright or dark? Dark. So it will appear more dark, right? So equatorial region appears as dark. ठीक है? अच्छा, which like a radiation will create more albedo? Vertical radiation or tangent radiation? Like a vertical will absorb more, tangent will reflect more. Reflection happens more with the tangent one. So that is how, in equator we have more absorption, in poles we have more reflection. ठीक है ना? That is the reason why we have the equator is also very hot and poles are cool because of the albedo phenomena. ठीक है? तो लिखो फिर से आप लिखो. What is albedo? What is albedo? So, अभी लिखना नहीं है आप बताओ चलो. What you have learned? Albedo? हाँ? हाँ, yes, the reflectivity ना. तो लिखो पहला. It indicates reflectivity. Reflectivity. ठीक है? And also it indicates brightness of the surface. So write brightness. Second point, list points. I'll give you the definition. Let us list reflectivity, then brightness. अच्छा, एक चीज तो बताना भूल गया मैं. So we have a cropland, then forest land. What is the albedo of a water? Maximum or minimum? Minimum. Water has a minimum because it absorbs all. Why water absorbs all? आपको लगता होगा नहीं shining surface है. नहीं. Water में sunlight penetrates inside. And that is why ocean appear what? Bright or dark? Dark. That is why ocean appear navy blue color. If you are going to see the earth picture, even in the space you will find ocean is very dark, black color. It hints that energy is absorbed. Right? So ocean has, which one is having a maximum like a potential to reflect? Snow से भी ज़्यादा. Desert तो second number पे. हाँ, very good. Clouds are having a maximum potential for this one. ठीक है? अच्छा. Crop के बाद forest then ocean. Forest में हाँ. हाँ, reflection. क्योंकि ओशन में ना आपको लगता होगा ना कि पानी चमकता है, आप तो ऐसे देख रहे हैं ना, क्योंकि उसमें वाटर हैज एन दिस टेंडेंसी लाइक वेव बनता है ऐसे. दैट इज व्हाई समटाइम वाटर लाइक इट गिव्स अ सेंस दैट light is reflecting back, but it absorbs most of the light because sunlight does not like stop here on the surface, it penetrates inside. So that is why ocean absorbs most of the light. वो तो कलर का कॉम्बिनेशन है कि देखो कलर कैसे होता है, हाउ वी हैव अ कलर, कि why this is black, it absorbs most of the light, all light. Why it is white, it reflects all. वो क्या चीज रिफ्लेक्ट कर रहा है उसी से लाइट के कलर होती है. ब्लू कलर इज वेरी क्लोज टू द ब्लैक, दैट इज व्हाई इसमें. ओके, देन we were discussing a point on albedo. We are trying to create a point ना where albedo का. तो albedo में क्या होता है, which one is the main prominent component? Cloud. अच्छा, what is the nature of an albedo? कैसा होगा albedo? Short wave or long wave? Short wave. Short wave. हमने डिस्कस किया था ना how it is different from terrestrial radiation. In terrestrial radiation we have absorption, and then we have a radiation. So terrestrial radiation is after absorption or before absorption? After absorption. And albedo is without no absorption. ठीक है? तो it is what radiation? Short wave. And visible rays, है ना, visible rays, क्योंकि वही रेज आ रहा है वही वापस जा रहा है. अच्छा, अब ये बताओ जरा, ट्राई करना, the all bodies as earth has an albedo, it is a fixed or variable? हाँ, why variable? Okay, it is variable. 35 is not fixed, sometime 34, sometime 20, but maximum is 35. Why it is variable? Because of one reason is the position. And cloud का formation क्या होता है? It is variable, different time. So the value of a albedo is fixed or variable? Variable. ठीक है ना? It is variable. It is. हाँ, why do clouds reflect? Because what is cloud? अच्छा, अभी पूछो doubt. What is cloud? What is cloud? Air parcel. Water vapor is. Do we have water vapor in this air which is we are breathing? Yes or no? No air is without water vapor. Even in desert you will find water vapor. Right? All the time water vapor is present. But what is cloud? Cloud has a two component. Water drops and ice crystals. Ice crystals. So, if you would be having an idea, the air parcel having water drops or ice crystals are qualified as cloud. So, the cloud having a dominance of ice crystals, they will appear what type of cloud? Dark or bright? Bright. And having a more of the water drops, they will appear dark. That is why we have two types of cloud. Ice loaded, water drops loaded. So normally what happened, cloud has these features. Water drops locate here, ice locate there in the highlight. So that is why they reflect more. Ice has a tendency to reflect. That is why. Ice particles they located in the higher position of the clouds, that is why they reflect more. Okay. So clouds. अच्छा, और चलो और बताओ. What is the albedo? It is same in all part of the earth or different parts? Different. Maximum albedo occurs where? On equator or poles? Poles. Do we have value of an albedo? Albedo का value है क्या? हाँ, it is variable. Okay. What is the value if there is an all-time albedo, like whatever the albedo we have, if everything will going to absorb, the warming would be very rapid then. So yes, it has a role in balancing the atmospheric temperature. तो लिखो आप albedo. Albedo, right? Albedo is measured. Albedo is measure of the Earth's ability. Albedo is the measure of surface ability. Surface ability. Albedo is a measure of surface ability to reflect incoming solar radiation. Incoming solar radiation. It acts as Earth's natural sunscreen. It acts as Earth's natural sunscreen. Sunscreen, comma, determining how much of the sun's energy is absorbed, determining how much of the sun's energy is absorbed or bounced back into space, or bounced back into space, bounce back into space. ठीक है? ओके, हाँ. Desert plays a prominent role in absorbing solar radiation, reflecting solar radiation. पर वो उसके पास ये भी रहता है, like it absorbs also, like it does not reflect all. It reflects, but it absorbs a noticeable, like what amount of the heat. So deserts, like it has a role in creating albedo. Only 30%, 70% is absorbs. इसलिए वो dangerous हैं deserts, है ना? It does not mean like if they are reflecting that they are participating in the cooling of the earth, but because yes, around the different landforms, desert plays in a major role in reflecting, but like it also absorbs. जितना आता है ना वो absorb होकर के heat energy में बना लेते हैं. Water does what? It absorbs and it does not let it be there in the sensible heat. It turns into latent heat. Plants absorb. It does not let it be in a sensible heat. It makes in a what? Evapotranspiration से they create water vapor. Photosynthesis से they make food. वो बाकी लैंड जो है ना दूसरे काम पे लगाते हैं एनर्जी को, बट डेजर्ट क्या करता है वो पूरा एब्जॉर्ब करके रख लेता है एंड उसी से गर्मी चलती है बहुत ज़्यादा. सो राइट, इंसुलेशन के बारे में भी लिख लो एक पॉइंट. राइट, इंसुलेशन, one line on insulation. Right, insulation is a radiation energy. Insulation is a radiation energy from the sun, that is received by Earth's surface. That is received by Earth's surface and atmosphere. That is received by Earth's surface and atmosphere. Atmosphere, full stop. It is the fundamental driver of Earth's climatic system. Earth's climatic system, comma, weather pattern, and numerous biological processes. Numerous biological processes. Earth's climatic system, comma, weather pattern, and numerous biological processes. ठीक है, rest तो you will be having ना write ups में मिल जाएगा, right? Now what we have learned, we got an albedo, concept of albedo, concept of insolation. Now what amount of the energy left? 65, right? Now what happened to this 65? What happened to this 65? Out of this 65, we have earth, and this side here, we have insolation coming, and the sum got reflected. Acha, it is reflected from where? From surface only or from atmosphere also? Keep this thing in mind, na? Like UPSC once have given us this question, कि albedo is only a land phenomena. No, it is a land as well as atmospheric phenomena, because it is mostly from the clouds. Clouds plays in a very important role, right? Okay, so when we have the insolation coming and it is getting reflected, reflection happens from the, like this side, that side. So we have a 65 unit is left. 65 unit is left. Out of this 65, only 51 will going to absorb by earth. And this 51 units will going to turn into terrestrial radiation. Once it is absorbed, it is going to release, it is a terrestrial radiation, right? That is why we call it this one, this 51 is known as effective radiation. Effective radiation. Radiation. Effective radiation. ठीक है? 51 समझ में आया effective radiation? ठीक है? क्या होता है? यस. किसमें? उन्हें बैठ के किसमें? हाँ. नहीं अभी नहीं रिफ्रैक्शन अभी तो we have seen 51% है ना. Now what going to happen to the 14%? यहाँ पे you will see refraction, scattering है ना. The refraction, this happened to the 14% here. हाँ वहाँ पे refraction होगा. ठीक है. तो I will take up this. So we have 15%, 51% is absorbed. Yes.
Sir, so all terrestrial radiation can be called effective radiation?
नहीं, wait, that is what my point is. What is effective radiation? It is a part of terrestrial radiation or solar radiation? Effective radiation is solar radiation. It is that part of the solar radiation absorbed by the atmosphere. Absorbed. Another effective radiation is a solar radiation. It will not entirely going to turn into terrestrial radiation. Okay? So is that idea clear about 51%? Out of 100, when the 100 is coming, when the 100 units are coming, 35 gone here. Now 14%, out of this 14%, some are going to consume in scattering, refraction and all. Acha, what happened due to the scattering? It creates a color of a blue sky, है ना. बड़ा interesting चीज बता रहा हूँ आपको कि have you noticed sky? It is what distance from surface? Can we touch any day blue sky? Possible? It is possible. You can touch and forget about the touching. There is a possibility you can go beyond blue sky, because the blue sky happens where? Of 10 kilometers from the surface. Scattering happens where? The moment the tropopause starts. Because blue sky, otherwise what is the color of a sky? Space, black. Right? So blue sky is a 10-20 kilometers away from the surface. It is there in the troposphere, ozone only. Got this point? So I'll let you see also. One day what happened, one man was started jumping. There was a competition, who will going to jump from highest point. So some have made an attempt to jump from the mountain top. Others have made an attempt to jump from like some aeroplane and all. One day, one man decided that he's going to break all record, and he went to stratosphere, and from there he jumped. So moment he was jumping from the stratosphere, that was a picture. I'll let you see like whether it is possible here. So I'll let you see in the coming class because it will going to consume time searching that picture. So the moment he jumped from that point, the visuals gives an impression that there's a dark space, dark sky, and there is a layer upon a blue sky. And then we have the earth was appearing from that space. So he jumped beyond the blue sky. Why sky is blue? Because of the scattering. And it happens where? In the atmosphere. In the upper layer of the atmosphere. That is why blue sky is very close to us. And blue sky is a phenomenon of night or day? Day. That is why it appears into day. Scattering happens into day. That is why it appears into day. Right? So, out of this 14, some get scattering, right? And some get absorbed by ozone, and some got absorbed by clouds also, clouds also absorb some point. Okay? So let us draw, isko draw kar lo. So this is a story of incoming. This is a point of an incoming. पूछो आप कौन सा डाउट है? अच्छा उसका क्या हुआ? उससे भी अच्छा एक बताता हूं मैं आपको. There's a drink called as Red Bull. याद है ये? हाँ, that drink actually is sponsored. Red Bull is an ordinary drink of Malaysia. It is a very ordinary drink. One day what happened, one Australian went to Malaysia. He saw one very unique drink was there in the corner. He asked, give me that drink. He find it very energetic. He said, I want to have the ownership of this brand. He purchased from the Malaysia. And the Australian gave a name as Red Bull. And only to advertise, he sponsored that event. Which event? When the man went to space and jumped from there. So like it was a Red Bull who actually like helped to let this jump, sponsor like this jump. And it was so popular that it also helped Red Bull to become a popular. Right? And that is because when the Red Bull have gotten this advertisement in the market, Coca-Cola started losing their market. Because the people have started looking this drink as an energy drink. And also have a less calorie and all. So to counter Red Bull, Coca-Cola has created a new brand, Diet. Coke Diet, suna hai? The Coke Diet is only on the reaction of the Red Bull. Forget about this. Like one day what happened, I'm not going to run here, you just go and watch. Some man has decided even to break that record. Which record? Stratosphere se kooda tha na wo. Usne bola ki okay, he has jumped from the wearing a parachute. I am going to jump without parachute. Right? He did what? He put a net on the surface and he went very far away and jumping and getting an accuracy is very difficult. You might have played cricket or you have catch in a ball. When we throw ball up in the sky, when it comes, it does not follow a straight line. It has a curvature like. It was not so easy. So he went up, like with the plane, he flew up, and then from there he jumped. And the net was of this room size only, that room size only, and he jumped. And what happened? वो आप बताना कल देख करके, मैं नहीं बता सकता. You go and watch. And the man who jumped without parachute. ठीक है? Is that idea clear? अब तो ये साइंटिफिक फिजिक्स वाले सर से पूछना. I know you know the answer. मुझे पता है आपके पास आंसर है भाई, इट इज ड्यू टू द वेवलेंथ, है ना, किसी का वेवलेंथ छोटा रहता है तो टकरा करके फैल जाता है. समवन इज हैविंग अ लॉन्ग वेवलेंथ, इट डज नॉट लाइक रिफ्लेक्ट इजीली. ओके, राइट, डन. नाउ राइट outgoing का features, outgoing. What happened to the outgoing? So this is a story about incoming. तो let us write, इसको लिख लो आप पहले, हीट बजट का. राइट. हाँ,
एक डाउट था. सबने बोला कि विंटर में जो टेरेस्ट्रियल रेडिएशन होती है वो ज़्यादा होती है, लेकिन अगर इनकमिंग सोलर रेडिएशन भी कम होगी तो ऑटोमेटिकली वो भी कम होगा, तो फिर जॉब भी कम होने वाला है.
क्योंकि एक्चुअली होता क्या है, लेट अस राइट, आई विल एक्सप्लेन इसको ना. देयर आर सम प्लेसेस विच आर कॉल्ड एज रेडिएशन विंडो, उसकी कूलिंग तो और भी कम होती चली जाती है. विल डिस्कस, अभी उसको बताता हूँ. इसमें विल गोइंग टू सी latitudinal distribution of a temperature, a heat budget, there we are going to see that point. So write heat budget. Right, the heat budget is the Earth's, heat budget is the Earth's balancing act between incoming solar radiation bracket में insolation and outgoing terrestrial radiation at full stop. Right, this equilibrium maintains a relatively stable global temperature, comma, crucial for life sustaining phenomena, Right, next point. Radiation energy from the sun, comma, which is primarily short wave radiation, bracket में visible and ultraviolet, fall on the earth, ultraviolet, bracket close, fall on the earth, providing the warm condition which is crucial for life sustaining and diverse process. Right, next point. Albedo, that comma, Earth's reflectivity, albedo, comma, Earth's reflectivity dictates how much of these solar energies bounce back into the space, surface like ice and snow surface like ice and snow act as a potential reflector. Act as a potential reflector. While the oceans absorb more energy, right? Third point, right? Out of 100 units, Earth system absorb 65 units. 65 units. Full stop, right? Out of 65 units, comma, 51 units are absorbed by surface. 51 units are absorbed by surface, which is known as effective radiation. Full stop, right? Whereas 14 units absorbed by atmosphere, 14 units which are absorbed by atmosphere in a following processes, such as scattering, breaking of ozone molecule, and absorption by clouds, ठीक है. Now this is a incoming story ना. अब outgoing देखो क्या होता है, what happens to the outgoing. So 51% is within a surface, land, and 14% is with space, with atmosphere. So I'll make this point as 14% is with atmosphere. Okay, like a percent in the sense I'll say units. 14 units, and we have 51 units. Now what happened out of this 51? So total altogether we have 65. Now out of this, 17 units goes to the space. How much? 17 only. 17 units goes to the space uninterruptedly, right? Without any obstruction. So it moves there. So which one goes to the space? Terrestrial radiation. And it brings what energy? Which heat energy? Sensible. So it will let the sensible heat energy reach where? To the space. Okay, to the space. So more the energy will reach to the space, cooling starts. Now it happens mostly from where? ये ऐसा कहाँ पे होता है जहाँ पे cooling is very rapid? Like which part of the land? Mountains. No? First is the mountain top. It is the mountain top from where the cooling is very rapid. Mountain top. Terrestrial radiation loses to space very quickly. Why? Because the short distance. Second, what obstruct and stops terrestrial radiation? Water vapor and greenhouse. These are less in number. Okay. So that is on a mountain, and that is why rapid cooling results into ice caps. Okay. Second is deserts. Deserts also has one of these phenomena. There the rapid cooling occurs. Why? Deserts are having what type of air? Dry air. Dry air permits rapid cooling. And rapid cooling happen when? During day or night? Night. And that is why somebody from the desert area will tell you the nights are unbearable in terms of the cold condition. One cannot leave without blanket. You know this? Blanket is very much essential in deserts, in summers also. That is why we have deserts and mountains. Deserts and mountains together is known as radiation window of the earth. Radiation window of the earth. Window of the earth. Earth के ना इनको radiation window. What is the radiation window indicates? A rapid cooling. Rapid cooling. ठीक है? This was a question. कि like which of the following are the radiation window ना? The mountain top and this two. So let us see. फिर लिख लेना आप. तो देखो out of 51, 17 units have lost to the space. It happens from where? From the mountain tops, from the deserts. But water vapor is present in the atmosphere. So it is going to absorb. So 17, so 34 units are absorbed by atmosphere. 34 units. How? By convection, conduction, radiation. So now atmosphere has what number of units? 48. This two together is a 48. Now from here it will lose 2. From here it will go to the space 48. So the energy is lost from surface as well as atmosphere. This. ओजोन के पास भी है ना, तो इसीलिए 48 यूनिट्स लॉस्ट टू द स्पेस. सो नाउ 48 plus 17 is equal to 65. This is how the things balanced. है ना, तो इसको ड्रॉ कर लो. Let us draw. And do it fast, because if you make a delay in drawing, copying in this all, we're going to lose those exercise. That exercise is the most valuable exercise. Which one? Case studies and related exercise, and a map work also. Case studies are very important. So done? तो लिखो आप. Right, 51 units of terrestrial radiation. 51 units of terrestrial radiation escape to the outer space. Escape to the outer space. लिखो तो. 51 units of terrestrial radiation escape to the outer space. ठीक है? Escape to the outer space. Full stop. Right. In that 17 units. In that 17 units are directly escaped. In that 17 units are directly escaped to outer space. Outer spaced. Not absorbed by atmosphere. Not absorbed by atmosphere. ठीक है? Like bracket में लिखो, through deserts and mountains, not absorbed by atmosphere, bracket में, through deserts and mountains, ना? And bracket में लिखना, these are known as radiation window of the earth. These are known as radiation window of the earth. These are known as radiation window of the earth. right? Next point, right? Whereas 34 units are absorbed by atmosphere. 34 units are absorbed by atmosphere. 34 units are absorbed by atmosphere. Full stop. Right now, atmosphere has absorbed total units of 48. Total units of 48. In bracket write 34 plus 14. 34 plus 14 units. 14 units. Right. Again 48 units. Escape to outer space from atmosphere. Okay, right? Acha. How this 34 unit is absorbed to the atmosphere? Through three processes. No? Right? The 34 units absorbed to the atmosphere by the process of conduction, convection, and absorption of terrestrial radiation. ठीक है. Now let us read this case study and we're going to see the heat budget का थोड़ा better understanding will come. ये case book studies है ना, तो I am reading this one. It will give you the better idea, more idea. So does deforestation have a role? Deforestation का forest का role है क्या? What role forest plays? In absorption or reflection? Absorption. ठीक है ना? Deforestation क्या करेगा? Is going to reflect more. हाँ, absorb नहीं होने देगी. So I am reading this so that we all going to write ना one answer ना last में लिखा है यहाँ पर. So I am reading ना this case studies deal into like the relationship between deforestation and the albedo, far-reaching impact of first one ना deforestation and heat budget disruption in the Amazon rainforest. ठीक है, तो मैं इसको पढ़ रहा हूँ, ध्यान से सुनना है, आपको अंडरलाइन करना है, and then we'll attempt creating a paragraph. ठीक है. Trees plays a pivotal role in water cycle through evaporation, where they absorb water from the soil and release its vapor into the atmosphere. Deforestation disrupts this process, leading to a decrease in the moisture in the air. Impact reduce the evapotranspiration release to the less cooling effect, and the latent heat of vaporization is not utilized. This results in a higher temperature and drier conditions in the deforestation. तो इसको अंडरलाइन करो आप. रिड्यूस इवापोट्रांसपिरेशन है ना, एंड ट्रांसलेट इनटू लेस कूलिंग इफेक्ट. अच्छा, सबके पास है ये? सो अच्छा, इट विल टेक टाइम ना. ओके, ठीक है. अच्छा, should we take one more topics so that we're going to take two case studies at a time? एक टॉपिक और देख लें, है ना. चलो इसको फिर उसमें देखते हैं. we'll have 10-15 minutes left. Write one more topic. लिखो आप temperature inversion. Come on time, na? It is why you have not received on time, because things distributed before you enter into a class. It will take time. अभी देखो इसमें अच्छा concept था. We would have discussed good point on these write-ups. ठीक है. So let us see temperature inversion. Temperature inversion. So, what happened that normally when we go from the surface up, है ना, तो होता क्या है, when we go up, normal condition, na? What is a normal condition? Normal condition. So when we go up, so what happened? Temperature, we have lower layer, upper layer, upper layer. Atmosphere का दो layer है ना? Where do we have more temperature? Lower layer. So we have temperature of a lower layer is high, upper layer is low. So this is warm. That is warm. This one is cool. Why the upper layer is cool, lower layer is warm? Because we have more absorption of sensible heat energy, more concentration, more water vapor. Okay? And what happened that when we go up, as the absorption is more, we have a warm, cool, cold. That is how the trend happens. Now, in some season, when the nights are longer, terrestrial radiation keep on working right from sunset to sunrise, so that surface becomes super cool. So it will go to the space. Now, what will go to the space? Terrestrial radiation, letting this sensible heat energy reach to the space. तो sensible heat energy को अगर terrestrial radiation ने space में पहुंचा दिया, the surface will start losing temperature and the surface will become cool. And if we have a more of these reaching to the space, the surface will become super cool. ठीक है? Surface will become super cool. देखो ये बहुत important concept बता रहा हूँ. Once you'll understand the concept of temperature inversion, you will understand many other, like a base for other concept in environment. कि what is causing problem to the Delhi, why air is polluted in Delhi, when the air is very unhealthy. So normally what happened, the temperature declines with an altitude. Now in temperature inversion we'll see temperature will increase with an altitude. उल्टा हो जाता है. Lower layer will become cool layer and upper layer will become warm. Now how come it happens? It is because when we have some place will get in a chance to let their sensible heat energy reach to the space, so that loss is very great and so that the drop is very noticeable, temperature of the surface land will become super cool. तो ऐसा कहाँ पे होगा? In a windy condition or calm condition? Calm. Windless condition? Because when the wind will come, it will disturb pattern of movement. तो पहला condition क्या चाहिए? Calm condition. अच्छा, when do we have net loss is more? Net loss. In a daytime or night time? Night time. What type of night will support more loss? Longer night or shorter nights? तो हमने क्या क्या देखा? Calm condition, longer nights, okay. Then उसके बाद क्या आता है? What type of sky will permit? Clear sky or cloudy sky? हाँ, clear sky. Why not cloudy sky? Because just a moment before we have seen cloud. Cloud is what? Is ice, right? It's crystals, water. If we have these bright clouds, they do what? They reflect. They reflect. ये question था ना? This was a question 2020 में. Why in the cloudy days the temperature of the atmosphere increases? Notice किया ऐसे? नहीं. In summers, अभी देखना जैसे कि थोड़ा सा भी cloud होगा ना, temperature of the atmosphere will increase a bit. It gives a hint that the rain is coming. लगता है ना ऐसा? Why it happen? Because cloud has a tendency to reflect radiation. ठीक है ना? So what terrestrial radiation is going to the space, come back again. The cloud reflects, right? So it is because of the reflection. So cloud will not let these two go to the space. So what type of sky we required? Clear sky. तो हमने देखा क्या? Calm condition, clear, and then longer nights, right? And clear sky. अच्छा. What type of air will permit quick radiation? Moist air or dry air? Dry air. So dry air will permit quick radiation, है ना? So dry air will permit quick radiation. Okay. So when these conditions are fulfilled, कौन सा? Calm air, dry air, long winter nights, and then clear sky, है ना? The surface becomes super cool and becomes so much cool that the temperature इतना cool हो जाता है ना, तो temperature क्या होता है? यहाँ से यहाँ नीचे transfer हो जाता है. Atmosphere का जो temperature है, it will transfer due to conduction. Conduction याद है? When the temperature transfer due to contact. So यहाँ पे क्या होता है? Because of the conduction, temperature T1 is greater than the T2. Temperature transfer, conduction से, that is why surface become hot, air become hot. पर winters में क्या होता है? What happens there in this time? Due to the conduction, the temperature of the air loses to the surface. The surface becomes super cool, and that is why this air become cool. What is hot here, it become cool, and the conduction does not occur there in the upper layer. Conduction occurs only with the contact. So air is a bad quality conductor of heat. That is why conduction does not happen. So daytime में जितना ये warm है ना, वो उतना warm रहता है. Let us suppose it is in a 30-degree warm, 15-degree warm, right? In the night it is, let us suppose 10, but it will become 0. है ना? So that is how temperature inversion occurred. कि the warm air is located above cold air. It happened due to conduction. ठीक है? फिर से देखो आप. Let us see again. In some specific condition, which conditions? Calm air, clear sky, longer nights, clear sky, है ना? Dry air, clear sky, and what was the windless condition? Na? Windless condition. Surface becomes super cool. Why surface becomes super cool? Land gets an all time to let their sensible heat energy to the space. What is space? मैंने बताया था, what is space in geography? No return. Loss for always, loss for goods. So the surface becomes super cool, and when the land becomes super cool, the air which holds in temperature, it loses to the surface, and the air itself become a cool. And that is how the warm air is sitting on the cool air. And due to this, condensation starts. Condensation. आपने notice किया है कि when you are going to put some warm water, warm milk in the refrigerator, after some time water drops develops, उसको बोलते हैं condensation. And due to the condensation, water drops develops, between these two layers, and air parcel with the water drops are known as clouds. Clouds will form. What type of clouds? Lower layer clouds, surface clouds. Surface clouds are known as fog. इसको कहते हैं fog. Is this idea clear? Let us see again. ना फिर से देखते हैं. Normally this is a train. temperature of the lower layer is warmer because of the absorption is more prominent. But in some specific condition, when we have 5 conditions are fulfilled, there is a rapid cooling. Why rapid cooling? The terrestrial radiation get no disturbance. Water vapor is absent altogether. It is not going to absorb this. In that way, it is going to lose this energy to the space, become super cool. Now air in contact, due to conduction से मैंने बताया था temperature transfer. Due to conduction, it loses its heat energy to the surface and becomes super cool, right? And become a cool, and but the conduction does not happen here, क्योंकि ये contact में नहीं है ना. So that is why it remain warm, and this is the reason why the lower layer become cool, that will become warm. ऊपर में तो cool again है, तो we have a cool, warm, cool. So one warm air trapped between 2 cool layers, right? यहाँ तक समझ पाया आप? अब देखो क्या होता है. If you are going to throw smoke, आपने कुछ smoke pollutant डाल दिया इसके ऊपर, and warm air has a tendency to rise, है ना? So the smoke will rise, it will go up. If you are going to throw in smoke here, some pollutant product in the air, will it going to rise? नहीं, क्योंकि cold air has a what tendency? To rise or to sink? Sink. So now whatever the things will eject in the air, it will going to concentrate, and diffusion would be less. Now the air will become healthy or unhealthy? Unhealthy. तो ये आइडिया समझ पाए आप? तो लिखो टेम्परेचर इन्वर्जन. अभी इसको मत ड्रॉ करना, पहले कॉन्सेप्ट डेवलप करते हैं. अभी यू हैव नॉट क्लियर कॉन्सेप्ट. कॉन्सेप्ट अभी होगा जब आप क्वेश्चन आंसर कर लोगे. तो लिखो दो, राइट टेम्परेचर इन्वर्जन. ठीक है, कोशिश करो आंसर देने का ना, उसी में आपके सॉल्यूशन पड़े. लिखो, विच ऑफ द फॉलोइंग सिटी हैज पोटेंशियल, which of the following city has potential to create foggy condition, bracket में temperature inversion Ti, foggy condition temperature inversion during winter. ठीक है ना. और जहां टेम्परेचर इन्वर्जन हुआ, वेयर वी हैव अ टेम्परेचर इन्वर्जन इन विंटर, एयर विल हेल्दी और पॉल्यूटेड ना. ट्राई करना, आप देखते हैं. तो लिखो फर्स्ट मुंबई, सेकंड नागपुर, थर्ड राइट चेन्नई, फोर्थ कोलकाता. तो ट्राई करो तो कहां पे हो सकता है. इसमें से एक सिटी है जहां पे टेम्परेचर इन्वर्जन होने के चांसेस हैं. द आंसर इज नागपुर, है ना. गॉट दिस आइडिया. तो लिखो आंसर इज नागपुर, ऐसे टिक करो नागपुर. तो व्हाट यू हैव लर्न, टेम्परेचर इन्वर्जन इज कोस्टल फिनोमेना और इनलैंड फिनोमेना. तो लिख लो पहला पॉइंट, टेम्परेचर इन्वर्जन इज एन इनलैंड फिनोमेना. ठीक है ना, इनलैंड फिनोमेना. तो आप समझ पाए. हैव यू गॉट एन आइडिया? पॉल्यूटेड सिटीज आर लोकेटेड वेयर, इन अ कोस्टल रीजन और इनलैंड रीजन्स? इनलैंड रीजन. समझ में आ रहा है? तो हेंस polluted cities are located in inland regions. Polluted cities are located in inland regions. Okay, write more. और देखो question will give you the understanding ना. Okay. अच्छा, आप बता सकते हो क्या? Like a temperature inversion is very strong. ऐसे verbally बताना. It is the most strong. What time in a day? Just after sunrise, just before sunrise, just after sunset, just before sunset. Sunset or sunrise? पहले तो ये देखो. सनराइज, सनसेट का रोल नहीं है यहाँ पे ना, सनराइज। टेम्परेचर इन्वर्जन इज वेरी स्ट्रॉन्ग। ये देखो ये कब से स्टार्ट होगा, नाइट और डे? नाइट। द लॉस विल बी स्टार्ट जस्ट आफ्टर सनराइज, इट विल कीप ऑन लूजिंग जस्ट बिफोर सनराइज। हाँ, जस्ट बिफोर सनराइज। तो टेम्परेचर इन्वर्जन, फॉगी कंडीशन इज वेरी प्रोमिनेंट व्हेन, इन अ इवनिंग टाइम, नाइट टाइम और मॉर्निंग टाइम। हाँ, फॉग फिनोमेना इज अ मॉर्निंग फिनोमेना, ठीक है। तो एक पॉइंट दिस ऑल्सो राइट, फॉग फिनोमेना is a foggy phenomena is a morning phenomena. Foggy phenomena is a morning phenomena. Okay, ठीक है, clear है? Now write one more question. देखो, questions will give you the understanding, right? Arrange following cities. Right question, right? Arrange following cities with respect to the intensity of. Arrange following cities with respect to the intensity of temperature inversion, intensity of temperature inversion, bracket में foggy condition during winters, foggy condition during winters. I'll give you the simple questions, simple location. To write Delhi, Nagpur, then write Moscow, then write Kabul. So do you have a rough idea? Delhi, Nagpur mein, which one is in a higher latitude? Delhi. Between Delhi and Kabul, which one is having a higher latitude? Kabul. And the highest latitude is with Moscow. तो सबसे ज़्यादा dense fog कहाँ पे बनेगा बताओ, try करो. हाँ, answer is Moscow. Why Moscow? During the winters, the duration of night is longer, loss is more. Is that idea clear? अभी हमने देखा था ना, longer night. So out of these four, Moscow will have a longer nights. So which city is having a densiest fog? Moscow, followed by Kabul, then Delhi, and then Nagpur. तो इसको लिख लो आप. So it means what? Temperature inversion is increases towards higher latitudes. तो इसका आंसर, पहले तो आंसर लिखो, right answer. It is most in Moscow, then in Kabul, then Delhi and Nagpur, and write temperature inversion increases towards higher latitude. Increases towards higher latitude. ठीक है? Increases towards higher latitude. Yes. Huh? Have you written answer? Yes. Got answer or not? Yes. Clear a concept? Yes. So write temperature inversion increases towards higher latitudes. Higher latitudes. It means what? It is more prominent where? In a tropical country or temperate countries? It is more prominent in temperate. ठीक है? It is more prominent, लिखो आप. It is more prominent in temperate countries. It is more prominent in temperate countries. It is more prominent in temperate countries. ठीक है? It means what? Where do we have a possibility of more polluted cities to be located? Temperate or tropical? Temperate. In fact, it was earlier. London, है ना? ये जितने cities थे ना बहुत polluted थे पहले. एक नीचे वहाँ footnotes में लिखो आप. London smog 1952. London smog SMOG. नीचे footnotes में. इसमें news gather करना आप. 52. London smoke 1952. Rather than looking articles, see YouTube videos. I'll give you the articles, case studies. Huh? So got this point? Okay. नहीं अभी नहीं, क्लाउड अभी पढ़ेंगे आगे। बस अपना ये इतना ही रखना अभी कंडेंसेशन, बिकॉज इफ आई एम गोइंग टू इन्वॉल्व क्लाउड प्रोसेस ना, इट विल मेक कॉम्प्लिकेटेड। जैसे सम लॉज आर फिजिक्स वन, आई विल गोइंग टू गिव यू द पॉइंट। अब जैसे एक क्वेश्चन था ना, व्हाई स्काई अपेयर विबग्योर है ना, विबग्योर, सो इट इज शॉर्ट वेव, इट इज लॉन्ग वेव, फ्लक्चुएट्स लेस, लॉन्ग वेव फ्लक्चुएट्स मोर। तो डस्ट किसको रिफ्लेक्ट करेगा ज्यादा? Which one, which will going to refract more by the particles? Short wave or long wave? Short wave. इसीलिए violet and all reflect more, sky appear violet, it's blue, है ना, इसीलिए, क्योंकि short wave होने से उसमें reflection हो जाता है। We're going to see this in a coming class में से। हाँ हाँ, नहीं समर में नहीं होता। There are 2-3 types of winter inversion. We have a surface, this is a surface inversion, right? Then we have a mountain inversion also, valley inversion. There are 2-3, but this is the most concerning one. ठीक है, it is a winter phenomena. अच्छा, let us write more. लिखो और अंडरस्टैंडिंग डेवलप करने के लिए ना, राइट वन मोर क्वेश्चन। लिखो, अरेंज फॉलोइंग लैंडस्केप, arrange following landscape with respect to intensity of temperature inversion. Arrange following landscape with respect to the intensity of temperature inversion, highest to lowest, okay. So right, first is forest land, second line cropland, third right barren land, barren, B-A-R-R-E-N, barren, desert, barren land, fourth right coastal land, ठीक है। यू विल गेट सरप्राइजिंग आंसर, इसका आंसर बड़ा सरप्राइज करेगा आपको। द अर्लियर कॉन्सेप्ट वाज ऑन द लेंथ ऑफ द नाइट ना, एंड दिस इज ऑन द बेसिस ऑफ, इसमें कौन सा क्लॉज लग रहा है? मॉइस्चर, like see how come moisture comes into the air? First is water evaporation and then transpiration also, है ना। forest also supplies moisture, इसीलिए वो that article was having a moisture content ना। तो more the moisture, higher the temperature inversion or lesser the temperature? lesser, very good। तो try करो आप। हाँ, तो highest is in, very good, deserts, है ना, barren land, second is very good cropland, third forest and then coastal lands, wonderful, ठीक है ना। तो ये लिखो आप इसका कि every day in desert area in the morning temperature inversion cause foggy condition, ठीक है। The last question, let us write this one, right? Arrange the following, or like identify the region suitable for temperature inversion in India, during winters, temperature inversion in India during winters, ठीक है। तो write eastern coastal land, then write Ganga belt, Ganga belt. Then write Andaman Island group, Andaman Island group, Andaman Island group. Then write Eastern Himalaya, Eastern Himalaya. Eastern Himalaya is loaded with forest, ना, evergreen forest. तो कौन सा ऐसा जगह है जहां पे आपको लगता है कि टेम्परेचर इन्वर्जन होगा? Which place is the most suitable place for a temperature inversion? Answer is Ganga belt. So where do we have most polluted cities of India located? Ganga belt. Only Delhi is polluted or most of the cities are polluted? Most of the cities are. Delhi become high because it is the capital. Okay? Is that clear? Point clear? So let us write, likho. Write temperature inversion. So we'll write definition first and then we're going to see the content, rest of the content. Na? So write in normal condition, इसको ड्रॉ किया है? नहीं, कोई बात नहीं, चलो मैं बना दूंगा फिर से. Like write in normal condition, comma, atmospheric temperature declines with altitude. Atmospheric temperature declines with altitude. Atmospheric temperature declines with an altitude. At the rate of decline with an altitude at the rate of 6.5 degrees centigrade, at the rate of 6.5 degrees centigrade per kilometer, 6.5 degrees centigrade per kilometer, which is known as normal lapse rate, which is known as normal lapse rate. Normal lapse rate. Normal lapse rate. Okay. यहाँ पे ये बढ़ जाएंगे ऐसे ना. That is temperature inversion. Temperature inversion. So normal lapse rate. Right. Next point. Next paragraph. However, in certain specific surface and atmospheric condition, however, in certain specific surface and atmospheric conditions, surface and atmospheric conditions, surface and atmospheric conditions, comma, thermal condition of atmosphere, thermal condition of atmosphere, thermal condition of atmosphere are changed, thermal condition of atmosphere are changed, full stop, right? Temperature increases with an altitude. This is a state of temperature inversion. This is the state of temperature inversion where atmospheric temperature increases with altitude, where atmospheric temperature increases with altitude, increases with altitude. Okay, let us draw this diagram. Altitude, and this phenomena is known as temperature inversion. Temperature inversion. Temperature inversion. Is this two diagram clear? That is normal lapse rate, temperature decreases within a height, normal lapse rate, NLR, normal lapse rate. So write temperature inversion is classified, next point. Temperature inversion is classified into surface temperature inversion, second valley temperature inversion, valley, VALLEY, valley temperature inversion, third frontal thermal, यहाँ पे लिख दो surface temperature inversion TI, valley temperature inversion, frontal temperature inversion, and advection advectional temperature inversion. Okay, advectional temperature inversion. So we'll see all, but not now. When the respective topics will come, when we'll see current, we'll see advection. When we'll see pressure, we'll see valley. Because you aren't going to comprehend. Definition लिखना नहीं है ना, use करना है आपको. तो write surface temperature inversion. Write surface temperature inversion. Write surface temperature inversion. इसको ड्रॉ कर लिया, ये वाला ड्रॉ किया, इसको ड्रॉ कर लो आप. Done? To write surface temperature inversion is formed in winters. Surface temperature inversion is formed in winters in following atmospheric condition. ठीक है? Write first. Air is dry. Okay, dry air means no moisture or less moisture? Bracket में less moisture. Air is dry. Second, calm atmospheric condition. In bracket write windless. Calm atmospheric condition. Then cloudless sky. Then long winter nights. Okay, bracket में why long winter nights? For rapid cooling. Okay, write next paragraph. In above these conditions, comma, as there is a long and rapid cooling of surface of earth, comma, surface become extremely cold, super cold, extremely cold, full stop. Since air is a poor conductor of heat, comma, air in contact of surface becomes colder and air above it remains warm. ठीक है, फुल स्टॉप और डैश करके कॉज टेम्परेचर इन्वर्जन, ठीक है। अच्छा, what role we have, the rest of the things I am going to give you in case studies, ठीक है। case studies are important ना, तो just to give you one hint, देखो सोचते कैसे अलग है ना, keep this thing in mind, only with the thought provoking points are going to make your answer different, है ना। so I am going to read in this, we are left within a 5 minutes 10 minutes, okay, थोड़ा सा try to come class on time, this all kills time, right, and every efforts will give you the some edge on your competitors, अगर मैं एक चीज छोड़ दूंगा तो आप बहुत वैल्यूबल चीज मिस कर जाओगे फिर, and the real learning comes when we apply logic, क्योंकि ठीक है चलो एनसीईआरटी पढ़ लो अच्छी बात है, एनसीईआरटी से भी तो केवल यू विल अंडरस्टैंड फाउंडेशन ओनली ना, you won't appreciate means you won't going to get, because you can apply when you have in logic information. तो I am reading this, मैं पढ़ रहा हूँ फटाफट ना, एक क्वेश्चन करेंगे, बाकी आपका असाइनमेंट आप करना, फिर मुझे बताना कहाँ दिक्कत हो रही है. So reduce evapotranspiration. What is evapotranspiration? Evaporated by plants. So the tree plays a pivotal role in the water cycle through evapotranspiration, where they absorb water from the soil and releases it as a vapor into the atmosphere. ठीक है, ये पूरा अंडरलाइन कर लेना आप. What is evapotranspiration? Absorption from soil, releases to atmosphere. Okay. Deforestation disrupts this process, leading to a decrease in moisture in the air. Impact: reduced evapotranspiration translates into less cooling effect, as the latent heat of vaporization is not utilized. This results in a higher temperature and drier condition in the deforested area. ठीक है, drier condition in the deforested area. Okay. देखो, for evaporation से क्या होता है, कूलिंग होता है कि वार्मिंग होता है? वार्मिंग होता है ना, more moisture warming, but when the vapor dilutes further, vaporize, तो it gives a cooling effect. ये पता है, अगर आपके बॉडी में कुछ मॉइस्चर है, if you sit under fan, if your body holds in a moisture, if you sit under fan, when the water droplets vaporizes, cooling effect comes. So that is how the cooling effects will going to kill when we have deforestation. Okay. Reduced evapotranspiration translate into less cooling effect, as the latent heat of vaporization is not utilized. This results into higher temperature and drier conditions in the deforested area. I mean, specific examples. No? We have an examples of Amazon. So the studies have shown that the deforestation in the Amazon experiences a temperature increase of 2 to 3 degrees centigrade as compared to the intact forest, primarily due to the decrease in evaporation. ठीक है, increase albedo. So it also increase albedo, है ना, deforestation increase albedo. तो एक अंडरलाइन कर लेना, increased albedo. नीचे वाले पॉइंट का ये ना, deforestation. Okay, forest have a low albedo. Why forest have a low albedo? Photosynthesis, absorption, meaning they absorb significant amount of solar radiation. Deforestation have exposed soil and bare ground and have a higher albedo, reflecting more sunlight back into the space. Impact: increased albedo leads to less soil energy being absorbed at the surface, potentially offsetting some of the warming from the reduced evapotranspiration. However, the net effect is still an alter the heat budget and potential disruption of regional climatic pattern. Okay. Now, satellite data reveals that the deforestation in Amazon have 10 to 20% higher albedo than intact forest, reflecting more solar radiation and contributing to the localized cooling. ठीक है, तो deforested have higher deforestation. Underline रखना facts को. Now, change in the cloud formation and rain pattern. Forest influence the cloud formation by releasing the moisture and aerosols into the atmosphere. Deforestation disrupts this process, potentially leading to a change in the cloud cover and the rainfall pattern. Reduced clouds can lead to increase in the solar radiation reaching to the surface, further warming the deforestation areas. Changing in the rain pattern can cause water availability and disrupt regional water hydrological cycle. Research suggests that the deforestation in Amazon has led to a decrease in the rainfall in some regions, particularly during the dry season, and drought conditions and increases the fire risk. Okay, analysis. Comparing to the meteorological data and deforestation in forest areas reveals a significant difference. Deforested region consistently exhibit higher temperature and often experience a reduced rainfall. Okay. And then we have a quantifying impact. Scientific model, the biodiversity loss. Altered heat budgets and drier conditions threaten the rich biodiversity of the Amazon, as many species are adapted to a specific temperature and moisture regime. Then carbon storage, and then यहाँ पे Amazon has these issues, deforestation driven by the factors like agriculture, logging disrupts the balance and leading it. चलो ठीक है. Question आप लिखो, what is evapotranspiration? रफ में लिखो कहीं पे, right? What is evapotranspiration? What is evapotranspiration? So, what is evapotranspiration? मैं बता देता हूँ पहले. It is a process through which vegetation supplies moisture to air. ठीक है? एक तो ऐसा point बना दिया मैंने ना. It is a bookish content. What we have dictated. If I am asked you to write, if you are writing from this like a case studies to the answer, you aren't going to write different answer. So evapotranspiration क्या होता है? It is a process through which moisture absorbed from the soil released to the atmosphere. अब आप बताओ तो क्या दिखता है? What is evapotranspiration for you? चलो बताओ. What is evapotranspiration for you? Result of? Okay, it is a result of complex process, है ना? तो एक लिखते चलो आप नीचे लिखो. देखो कितना अच्छा आइडिया है. It is induced by complex process, है ना? It is induced by living beings or non-living beings. तो पहला चीज है ना, living beings. It is living beings. हाँ, it induce cooling effects in the region. Cooling effects. ठीक है. अच्छा, which machine, like a take water and eject water, which machine, what is the name of the machine which take water from somewhere and pump? So this evapotranspiration is like a pump. Which pump? It takes enough moisture from the soil, give it to the moisture into the atmosphere. This is what pump? Natural pump or biological pump? Like what is, okay, biological pump, है ना? It is a natural biological pump. So right, it is a biological pump. Is that point clear? It is a biological pump. ठीक है. अच्छा, is it an essential phenomena? It is essential. ठीक है. Why it is essential? Because it alters what? Cooling effect, rain pattern, regional water cycle, and ठीक है. ठीक है. तो it affects regional climatic condition. ठीक है. हाँ, ओके. Got this point? अब एक सेंटेंस लिखो जल्दी से इस पे. It is a biological pump. It is in a natural. हाँ, हाँ, it is in a like mostly dominated in a daytime, है ना? It is a daytime. एक आंसर लिखो 1-2 सेंटेंस का. Write one answer of 1-2 sentence. Question is, what is evapotranspiration? What is evapotranspiration? Not more than 2 sentences. Need not to cover all. 1-2 line only. It is essential or not essential, ऐसे करके. Read fast, loud, loud.
Evaporation is biological.
No, क्वेश्चन इवापोरेशन पे नहीं है ना. क्वेश्चन इज
Transportation is biological pump.
हाँ
It helps to earth for cooling.
हाँ, it induce cooling effect and eventually affects regional climate pattern ना.
The process of evaporation from plants result in induction of cooling effect and essential phenomena that in daytime also affect the biological processes of nature like nature.
Good, but you need to break into two sentences. लंबा हो गया sentence. हाँ, okay.
Evapotranspiration is a process of natural pumping of water vapors which carry heat from the surface and release them into environment around it, causing cooling effect. Thus, it marks the importance of the process in maintaining the climatic.
Very, very good, wonderful. हाँ, yes.
Evapotranspiration is an essential phenomena which affects regional climatic conditions with inducing cooling effects in the region. It is a biological pump and is introduced to complex processes by the human.
Like see, he has better inputs of those ideas ना. He has given a value also. आपके आंसर में it is led by complex processes. So it is not easy. So it means if it is complex, can we replace with a human induced technology? Replace कर सकते हैं क्या? नहीं कर सकते. तो यही चीज होता है. Can't be replaced, नहीं. तो we need to protect conserve. आपके उसमें आवाज आ जानी चाहिए. अच्छा ये देखो ये कितना concerned है. It is a complex process. Yes.
So evapotranspiration is induced by biotic factors and is essential for the rainfall patterns and climatic conditions of the area.
हाँ.
It also affects positively to the biodiversity, flora and fauna by cooling.
Okay. So but we need to touch it with a heat budget. ठीक है, बहुत अच्छा. Yes.
Evapotranspiration is a complex process that mostly occurs during the day. This essential process acts as a natural biological pump as it releases water from the soil into the atmosphere. Its importance is determined by its role in inducing cooling and maintaining rainfall.
Wonderful. It is even more complete. है ना? That is the way we need to. And you have noticed, every one of you are writing different answer. And that is the uniqueness of your answer. That comes with, it comes with discussion and ideas we generate from the thought. अगर मैं लिखने देता कि like it is a process from where the plants extract moisture from the soil and pump it into the atmosphere, तब तो ये सबके पास था ना. हमें कुछ अलग करना है इसमें. और अलग होगा when we'll do these exercise more often in the class. Only answer writing is writing in 200 words, 5 paragraphs. Only command on paragraphs, the rest of the things will come very easy. ठीक है, and now you are in a position to write PYQs. In the next class tomorrow I'll introduce PYQs, है ना, and we're going to work on a PYQs then after, tomorrow after, ठीक है. So do this and write rest of the answers. वो आपके ऊपर है, सारे answers लिखो आप, जो case studies मिल रहा है. In the manner I'll get in a chance to introduce more case studies. Tomorrow I'll see the temperature inversion और उसमें.